Welcome, everyone. So I'm Frédéric Perret, Marketing Manager of PowerSys, and I'm glad to welcome you, for this third day of our 2021 JMAG and PSIM Users Conference. So I'm going to share with you this morning, first, the available recordings of our yesterday sessions, and then I will present the agenda for today. So let me just share my screen with you. Okay. So you should see my screen now. Frank, is it okay? Can we see my screen?
Yes, we can see it.
Okay, thank you, Frank. So yesterday we had several sessions, and the recording will be available this morning. So you will have access to the presentation of Hamed Shob from PowerSys, the one of Elia Cipolato from Hexagon MSc Software, the one of Dr. Antonio Lazaro from Carlos III University of Madrid, and the one of Siavac Heidarzadeh of V Research, and finally the presentation of Amit Kumar from PowerSim. So do not hesitate to visit the video gallery of Huva, and you will have access to all this recording by this morning. Now today, what is the program of today? So let's see that together. So we will start, we have a last minute change. This morning, we will have a presentation at 9:50 a.m. of Yves Thiolière from PowerSys. So about integration study, new circuit control features to enable system simulation, including multiple models. At 10:20, Vladimir Semin from Institute of Digitalization of Electrical Drives from Heilbronn University will present how to use JMAG script editor to model electrical windings of any configuration. At 10:05 a.m., Michele Merelli from Engitsoft SPA, so it's our partner selling particle rack software, will present e-motors and e-axles designed by simulation. At 11:50 a.m., we will have a presentation from Taiful Hill, a better way to design and test motor drives. So this presentation is a little bit particular because Peter Gartner is not available, unfortunately. So we decided to display his recording. So the recording is already available in Huva. So you can watch it whenever you want. And for the questions, please do not hesitate to ask your question in the Q&A box of Huva, and we will transmit them to Peter Gartner so that he can provide you with an answer. In the afternoon, we will have the PSIM related presentations, and we will start the afternoon at 2 p.m. with Jordi Klaus Garrido from UPC. His presentation will be about the behavioral modelization of a residential microgrid using PSIM lookup tables. At 2:45 p.m., Egor Kulik from LLC CMC Vector will present AFE with a 3-level inverter, how to control it and its model. And we will end the day sooner than yesterday at 3:30 p.m. with the presentation of our partner PowerSim. So Amit Kumar will present a design of a high-performance motor drives. So now we can start the day. So I'm going to introduce Yves Thiolière, my colleague who will do the next presentation, and we start our session today. So Yves is born in 1981, and he received his master and engineer degree from the ENSIEG school in Grenoble. Yves joined PowerSys in January 27, and since then is working as an electromagnetic simulation engineer and is based in France. Yves is in charge of the overall support of our European customers using JMAG, and is also in charge of the customer trainings, our webinars, and is conducted also various simulation studies for our clients. So Yves, thank you to join us this morning, last minute for your presentation. Thank you again. So now the mic is yours.
Thank you, Frédéric. Can you hear me well?
Yes.
Yes, okay. So I'm going to share my screen. Okay, can you see my presentation?
Yes, it's perfect.
Yes, okay. So today I will introduce the new feature of JMAG v20.2. This new feature is the integration study. This is the agenda of the presentation. I will explain quickly the feature, the advantage, and the aim of this new feature. I have a quite simple demo model to illustrate what is this integration study, and then I have a bit more complicated model. Not so much complicated, of course. It's demo. I will show you the integration study. It's a coupling with the control. And I will take the opportunity also to show you the PostScript execution, composite view results, and creation of vector expression, which are a feature from the previous version, but maybe also a bit new. And then I will conclude with some questions. So here, this integration study in fact allows you to include multiple phenomena and models. So for example, you could have several different FEM models in one calculation. Those FEM models could be both magnetic or could be magnetic and thermal. You can also include control here. You can see here in this picture, you can have all this in one single study. At the moment, it's a bit limited. Just JMAG-RT could be integrated, but the aim of this study, of this feature, is really to be able to have multiple studies from different multi-domain. So you will have this feature will be improved in the coming version. That's just the beginning for this feature. Here is an example. So that's the examples Nicolas showed you during the presentation of Dr. Takashi Yamada. So you could see that in this circuit, there are several different RT model. So here this is the controller and the command for the motor. Here is the motor. This component is the JMAG-RT motor model. So JMAG-RT is a behavior table of the model. So inside this component, you've got the behavior table of your model, but you've got also another one here. This is the behavior table of the resolver. So it means you've got the real and true behavior of your resolver as well with your motor, and that's allow you to make a very fine command of your motor, and you've got the very accurate behavior of the motor plus the resolver. The advantage of this feature is that if you have now a circuit, just a circuit and a single circuit, you have no need to create some dummy shape, like, for example, just one element or something like that. There is no need of shape model or condition setting or applying material, dummy material. It's only circuit, and you can run only circuit calculation. Here you see it's only circuit can be set. So it means that you don't need also anymore some external circuit simulator. This control simulation could be run in JMAG alone. And of course, you've got the advantage because you know JMAG, you know the interface of JMAG, so you've got the advantage to use the classical response graph values So it's the same and usual procedure in JMAG. So the communication also between the FEA and the control is easy, quick, automated, and very stable. You can also review the control signal in a separated study. So now, in fact, it could be also reviewed in separated study. So it's more easy to be checked. So let's go for the demo model. Let's see if I have a JMAG-Designer open. Here it is. Okay, just quickly, I will first detail you what I'm going to do in this demo model. So here I will start to create a new integration model. That's the new feature. That's the new feature in JMAG. You need to create not a shape, not an express, but you need to create an integration model, an integration study. You've got the possibility also, because here we will have some control. So I need to import some variables, some equations. So you can import, as usually in JMAG, some equation. It is, of course, prepared for the demo. The circuit, then I will also import it. It's also prepared for the demo. Then I have just some studies, step control to specify, and then run the calculation, evaluate the results. So you see there is no shape creation. So here is my JMAG. So now you can see that I can here directly go there. Integration model, no needs to create shapes. And now I can also create my new study. Okay, so that's my integration study. Now it says integration study. And what I'm going to do is to import my equation. Okay, at the moment I have no equation, so I'm going to import that. So those are the equation imported. That's classical variables needed for the control, flux of the magnet, LDLQ, etc. So I click OK. And you can see in the tree view that also there is no condition material, only circuit, which is available. So if I click view, my circuit is now empty. You've got all the classical components you can have in the JMAG interface. So I'm going to import it because it's also prepared. And then this is the circuit. I will quickly review it. So here you've got the command for the amplitude and beta. It's converted to DQ system. Then you've got the PI controller here. It's a scriptable component. Okay, maybe you already know that. And then you've got the PWM component. Okay, and then here you've got the JMAG-RT model. So here in the JMAG-RT model, of course, you have to specify the table of your model. Okay. So now I can close the circuit, and I only have to go to properties and to specify here some steps number and delta t. Yeah. And now, so you see that I have many steps here. It's something like 1,800, but you will see that the calculation is quite fast because indeed it's just a circuit calculation. Okay, I need to save. Okay, so now you see 100 step has been completed already. So it's quite fast. Okay, I will maybe take this one, which is already solved. It's quick, but I don't want to wait for the demo. And so it's exactly the same model. You can see it's exactly the same model. And now you've got the results. And of course, you can check control signal. So here is, for example, the torque. Then you can select different things. So you can, for example, select the ID command and the ID of the motor. So here you can check that the control is okay. And of course, you can also create from those control signal your behavior, your response table. Okay, here show table, and you can also create some equation. So here, for example, the torque difference, P out, out power, and you can review, of course, all those quantities. So the post calculation is a bit classical. Okay, so my calculation is finished here, but I already reviewed the results. Okay, here is some picture again of the circuit and the resulting data, and here you see you can review the response table. That's classical. I would like to go now to this a bit more complex model. Still, integration study is the topic. Okay, but I'm going to run some motor model with some FEA model. And I will highlight the post-calculating script, which is used in this calculation, and also some relatively new feature. So here the goal is to create this integration study, okay? And so the command of the motor will be run here, the control of the motor will be run here, and some script will output some current point sequence that will be given as the input parameter for the FEA. Then the FEA model will be run, and all those will be placed into an analysis group for an easy calculation, easy run. So one click run the both. And then this is in fact a sequential calculation, but one click will run both, and I will evaluate the results. So let's check this model. So here is my my model. I've got, as I told you, an analysis group. I have placed those two analysis here into an analysis group. This is just for a sequential calculation. So if you go to properties, sorry, if you go to yes, properties should be here, order, yeah. So you see it's say not simultaneously, so it's a sequential coupling. Okay, so first the RT calculation is run, and then the loss after is run. So it means that this integration study will be run. So I can show you the circuit, edit circuit. So here it's, let's say, more or less the same model as previously, okay, except that those current will be outputted and will be will be extracted and placed into the 2D model calculation here, thanks to this script. Here you can see that I have a post calculation script here. So I can show you this script. Okay, basically this script is picking up the current values and placing this into the previous study, and this is made also with the setting of the post calculation script. It means this script could be totally generic, and you are going to replace the name of the output here and the name of the target study. So here you can see loss. So it means it's that. Maybe I can show you the name of the study. Yes, this one, loss. So it means that whatever is the name of the study, whatever is the name of the output control, I can here specify those names, and JMAG will know that the results of this script will be put in this target study, and the results mean those values here will be placed in those current E1, E2, E3. So those I1, I2, I3 are, if you edit the circuit, in fact, those values here in the FEA model. So the current calculated in this integration study, so in the control study, will be placed. So maybe it's already run, so I can show you here control signal, show. And I can so display only this. So the current. So those currents will be placed in this loss study when it's finished. And then I could run this classical study here with FM conductor. And I could run this study. And for example, if I check circuit current now in this study, you can see that this circuit has the current calculated. Of course, you can select also the number of electrical period you can use. And here you can review also very classical the torque and all the results. So let me take this opportunity also as well to introduce the mix component results. So here it is. You've got a new tab here. So you can in fact display a mix of all the contour plot, vector plot you have already created here. And of course, when you click here, you've got a new button also here. So when you click here, it's also it shows everything which is highlighted there. So magnetic flux density, contour plot, vector plot for current density, and flux line as well. No, flux line is not activated, I think. Yeah, flux line is deactivated. And it's also taking into account the view I have specified. Here I have specified view set point. So it means that the view is also changed. So if I go back here, you see that the view is also changed. So that's a new feature. And also you can create now some vector expression. So it means here, if I edit, you can pick up values of the table of the circuit and create new vector expression. Previously, you can only create some response graph. Okay, so now it's really vector. So you can pick up values from the circuit, create expression and output that, and you can then show this. Okay, I think that's all. Do I forgot something? Yeah, that's an analysis group, so I also explain. So feel free to ask questions, and feel free to try and to test this new feature. You've got some step-by-step tutorial available on the internet.
Okay. Okay. Thank you, Yves. Thank you for the good presentation. So for the question, I think I have 3 questions. So the first one is, how accurate is efficiency map generated by JMAG-RT model? Did anyone compare with experimentally?
Yes, of course, some experimental data are conducted. GSOL has some laboratory, and they have their own test bench. Some partnership with the university also are made. So yes, it's compared with measurements. It's also depending on the accuracy you want in the efficiency map and which assumption and which tool you are using. If you are using speed priority, accuracy priority, or lumped element, if you are taking into account the numerical correction, of course it's just numerical, it's not FEA. So it's depending how fast you would like to achieve your map and which assumption you are ready to consider. But if you are using the accuracy priority type, this map is a kind of parametric calculation. So it's in fact the real FEA calculation, working point of the real FEA calculation of the working points. So it's the same accuracy as a JMAG calculation, including all the 3D effect if you are using 3D model, including all the AC losses if you're also using FEA conductor. So that's very accurate.
Thank you. The second question is JMAG-RT model draw the efficiency map of conventional machine mostly. Is there any idea how to draw efficiency map from flux switching machine?
Oh, could you please say it again?
JMAG-RT model draw the efficiency map of conventional machine mostly. Is there any idea how to draw efficiency map for flux switching machine?
Nicola, you know if RT is available with a flux switching machine? I think yes.
So thanks. I think I already answered him directly on the website, but yeah, I think I will do it orally, so for the benefit of everyone. Maybe before answering this question, I will also sorry, mention the fact that right now we don't recommend RT to be the source of the creation of the efficiency map, since now we introduced, since I think two or three versions now, efficiency map study. This should be the place where you create efficiency map. RT is not the tool now to create efficiency map. It was in the past, but now please use efficiency map studies. So as the user pointed out, yeah, it's not possible to draw efficiency maps for flux switching machines. And it's not possible as well in Designer using speed priority. So we don't have like pre-made set implementation for those type of machines. But technically, if you create your own algorithm of point selection for your machine, you can then still draw the efficiency map using an accuracy priority efficiency map. So it's not yet implemented, but if you're savvy enough into selecting the operating points that need to be calculated for your efficiency map, you can actually do it. That would be my answer for this one.
Okay, so thank you for that. And the last question is, please explain how injectance LG-LQ is calculated for PMSM and wound rotor machine. Wound rotor machine.
I think like Mr. Miller mentioned, I think the best part would be to go to the lecture from Professor Miller and the website. He has some very, very good explanation. I don't think we have time right now to do a lecture on inductance of electrical machines. And I would wholeheartedly recommend the Green Book, as he said, if you want more information on how LDLQ inductances are calculated.
Okay, thank you, Mr. Miller, also for your Green Book.
Okay.
Okay,
I think we have a new question. Is how can we take into account the PWM current in the efficiency map? I think
yes, with the accuracy priority type. You can also check on the website of JMAG. There is an example available step-by-step tutorial. So you start with the speed priority and then accuracy priority, and it means you can completely customize the circuit. It's not anymore purely sinus calculation. You can have your PWM inside JMAG. And the efficiency map will be calculated using the last electrical cycles. So when you reach steady state, please check the tutorial on the JMAG website. There is a tutorial for that. So you can take into account PWM in efficiency map for sure.
And I think, sorry to take the ball, Yves. And I think tomorrow, when we're going to do the demonstration about efficiency map, we will show you how we can model those PWM currents in using accuracy priority efficiency map.
Okay. Maybe thank you.
I have
very
the
much.
last question. Sorry. Yeah, I got some new question. In the efficiency map generated by designer, how is the voltage limit taken into account?
Yeah, you've got some algorithm in the JMAG tutorial, in the JMAG efficiency map feature. So first you run some calculation points, okay, and then in the efficiency map creation you need to specify the voltage DC limit, and JMAG will search for the point working for this voltage DC limit, and will create the map that way with that kind of algorithm. So when you create first you run the calculation you run are some working point with some current values. So indeed, in the calculation of the FIA model, voltage limit is not taken into account. It's after, in the post calculation, when you create the efficiency map, then you specify the DC voltage limit, and then the algorithm is searching for the points that are fitting that voltage limit. Also, you can check the tutorial for creating this efficiency map.
Thank you. I think the question is
maybe it's time to switch to the next presentation.
Yeah.
Thank you very much for following this this session. Please go to the next one. So you need to start the next Zoom meeting from the UVA platform. Thank you, Didier. Thank you, Nicolas. See you. Bye.
See you. Bye.
Thank you very much. Bye.